Hello, everyone, and welcome to the third webinar of DataFlint. Be it good morning or good evening or good afternoon, depends where you are geographically. And I'm happy today to host Scott from Databricks.
Hello.
How are you? Good morning, Scott.
I'm doing fantastic. Coffee is fueling my body right now, and I'm very excited to talk Spark and talk ecosystem and everything else. So yeah, it's gonna be great. Good morning.
Cool. Happy to hear you. And as you were speaking, because I'm recording from Israel, we got it's not an alert yet, but there might be an alert soon. So if that happens, I'm gonna move my setup to the. It's an alert. Okay, I'm moving my laptop.
Okay.
So bear with me.
Yep.
We have a safe room at home.
Okay.
Part of oh, okay. I look really weird, but it is what it is, and we're
No.
gonna do our best
Yeah. This is
as
this is
long as the reception.
yeah. This is the first webinar I'm doing where like there's actually like an active potential attack going on as well. This kind of feels like it feels like a on the ground like news report versus like a Spark webinar. So please be safe.
Yeah. So I'm reporting live.
Good.
I'll update if there's something cool happening. But I'll move the focus back to you. So maybe let's start with tell us about the last 20 years of, I won't say Spark, but data engineering.
Yeah. So yeah, I mean, if you kind of roll back the clock, for me, a lot of this started when I worked at Yahoo. So kind of early on in the career, I got into analytics because of analytics for an iPad app that was called LiveStand, which was like one of like the first things that Yahoo created that was like, sort of like a Flipboard like environment. Um, so with all of that, that was like kind of my first like.
You said Yahoo, so that's a long time ago. They had the largest Spark cluster, right?
Yeah, they had I mean, that's like also like where I got into like MapReduce and everything else like that. So they had like the Hadoop users group there. At first I used to just go for pizza, but then I went for like learning to understand like what is MapReduce, why would you use it, why is it important for like analytics and things. And that was kind of like sort of like the kind of launch point for me. It's like I know that this is important to understand like user behavior, to understand why people do what they do, what's working, what's not working, all essentially through events, right? And for me, that was kind of like magic, and that kind of propelled me into gaming, propelled me into a lot of kind of different avenues as well. So like at Yahoo, I also worked on like Yahoo Games when Yahoo Games was essentially kind of like built back up again. This was around like 2011, and that's actually the
But
first time.
I'm curious, have you started like a software engineer that got
Yeah,
somehow by mistake into more MapReduce, or you said, oh, that's super cool, and now try to dive deep into it?
it was. So I think for me, like I started off essentially like in front end and building like applications like with
So
like.
in front end, yes,
Yep.
interesting. Usually
Yeah.
people come from back end.
Yeah, well, I think I had a kind of a different journey. So I think with the front end, it was kind of interesting to understand how things were built, what people would do, how they'd interact with it. And then analytics was kind of like my gateway into back end because it's like if we're going to emit data and receive data, what are we going to do with it? And how does that kind of flow work? And so for me, kind of over time, there was like the steady path towards analytics and like, high throughput analytical systems. And so around like 2011 or so, when I was working on Yahoo Games, that was also the same time that I got introduced to Apache Storm. So if you think about like the path to Spark, Apache Storm was essentially the first like gigantic, stream-based processing engine that I worked with. And that for me was kind of eye-opening, where it's like, nothing else that I've used before can run, up to 46 million
Hmm.
events a second on commodity hardware. It was for me, it was like eye-opening. Like this is really cool. What's next, right? And so, like for me, I worked in analytics for about 2.5 years when I was at Yahoo, across Yahoo Games, then across like we had something called like Guam, which is like our growth user acquisition management, And so it's sort of like, how do we get people into games? How do we understand why they play games? How do we understand how to give them better games that they enjoy? This is kind of like the same time that like machine learning was sort of getting a better name, right? We had kind of a data science, like kind of high tower when I was at Yahoo, but we then realized
Which year was it?
this was 2011 to around 2015.
Oh, so that's early. So that's even predates deep learning,
Yeah.
which
Yeah.
only came a
This
few
was like,
years later. Yeah.
yeah, this was all kind of collaborative filtering. So it's like,
Mm,
you know,
yeah.
yeah, what are the nearest neighbors doing who act like you? And then how can we derive that data? So we did a lot of stuff like in Redis as well. And so a lot of like our like ecosystem was essentially building different kind of sets of data that were in Redis that could then be combined back together like as an offline job to then provide like recommendations and to also show like what games are trending like right now, which are like, what's like the top end list of a specific type, right? And a lot of that is like kind of computationally expensive depending on how you do it. And so like, across like our entire games, like catalog, we would do this across all users within like Yahoo who actually played games. And we would have essentially like daily updates to recommendations and everything else like that. But that, for me, that was really fun. And then I worked on something called Flurry Analytics, which kind of predated like Firebase Analytics. And before Firebase, it was like the number one analytic provider for mobile across the whole world.
No, interesting. Yeah, I remember Firebase. I don't remember what happened prior.
Yeah. Well, this was like Flurry was something that had kind of like this rise and fall. So like Yahoo acquired
Oh,
it, and that was
yeah.
sort of
Okay.
kind of the tipping point, right? Um, but it was really good. That was like really where I really got to get my hands dirty with like the whole Hadoop ecosystem. So it's like, how do we create like gigantic, jobs that are, ingesting like 180 billion events a day, which was a lot back then. So Snapchat was one of our customers, and that was like one of the biggest jobs that we ran across like our cluster. And our cluster had like 1,000 nodes in like our Hadoop cluster. And that thing was always essentially burning up compute as it was running these daily jobs. Uh,
Yeah.
and then I went to Twilio, and Twilio is really where I got like the Spark. I got, my kind of like my feet wet, right? But I kind of went all in. So sort of dove into the deep end of Spark. And that was where I started doing a lot more streaming work as well. So when I joined
So
Twilio,
this was more a backend infra
yep,
aspect.
yep. Yeah,
Yeah, work.
I worked like platform, and then we also like
Mm.
we did something called Voice Insights. So it was insights for the entire company across like all of our customers to understand how like call flows worked. Did they sound good? Was the audio being received correctly? Did we have issues like within like the network topology across the whole globe that were causing problems? Could we pinpoint these issues and then raise it back to the customer? And so it was like technically like you'd think about a lot of that stuff now as like, kind of more machine learning-esque, right? Like a lot of like reinforcement learning to understand what endpoints work the best for specific calls, et cetera. But then it's like, well, you know, what other kind of variables and other information kind of affect that in real time? Because, the best provider of a call yesterday might not be the best provider of a call today because things in the world change, right? And so it's a kind of a continuous learning system that we created. And that for me, again, was another thing that was just interesting. So, up early, up late, just working on this stuff because it was really just, it made me excited. So we also built like, asynchronous deployments for like our own like bare metal Spark clusters
Oh,
back
wow.
in 2017, which made it easier for us to kind of deploy applications prior to us having like, any kind of like Kubernetes operator type support, all using kind of EC2 images that were, coming up asynchronously. So it's like, if I want to go and create an app and deploy it, and I want to do basically, standalone cluster, I basically go in, ship my code like I normally would. Cluster spins up. If it already exists and I want to use the version that's pinned from before, great. Roll off the old application, spin up the new application, pick up the checkpoints, and that's all essentially done as like a normal release process. So
So
all the stuff I
which
did
version of Spark was the
ooh,
first one you started work with?
1.6,
Mm.
way back in the day of like a
Yeah,
deep.
okay, okay.
Yep.
So in Twilio, it was already 2 point something, right?
Twilio is 1.6, and then we switched over to
Mm.
2.0, and like that was around I think 2017-esque, something like that.
Makes sense, yeah.
And yeah, so that was kind of like our dive into. We went from essentially kind of like Java Scala native to what is a data frame, right? And it's like that was like a big kind of evolution for us because we're used to like Cairo serialization and essentially just, marshaling normal Java objects and sending them around and figuring out why garbage collection is bad. And the data frame happened, and I was like, oh, all our serialization and deserialization time went away. What happened, right? And it was like, from before and after, it was like, oh, this is well worth like the upgrade for us. Um, but we ran around like 50 applications that were all running streaming off of streaming directly from Kafka. This is like predating a lot of like the Lakehouse ecosystem and any of the kind of open table formats. So we did a lot more
So
work.
I'm curious a little bit, what was the architecture? So where did you store everything? How you handle it? Like, give us 1 minute overview.
Yeah,
That's super interesting.
yeah. So we started off in S3 for all of our data, including checkpoints, and then we switched all of our data over to like an actual like Hadoop deployment. So we deployed essentially just like HDFS, right? We weren't using any kind of like node management. We weren't using like yarn scheduling. We're essentially just doing that because we were running 50 different kind of Spark applications. We were running into issues where we're getting 80,400s a second from Amazon telling us to stop writing to S3. And so because of that, we ended up moving over to Hadoop because we could actually write like 400 megabit, which was our checkpoint throughput rate that we had for like our clusters. And so that was just something that had to happen for us to kind of move forward at the time. So a lot of that stuff has gotten better nowadays, right? You can write better. You can basically shard to S3 in a better way if you want to run your own like, Spark platform. But at our time, we're like, well, what's the simplest fix for us to be able to continue moving? Because
Yep.
we got paged because we used to talk about like hockey teeth. This is kind of our joke. We had like our Datadog dashboards
Okay.
and they should look normal, but then at a certain point, it's like a
Hmm.
puck gets to the mouth and then we're
Yeah, you
missing
see
like
the.
segments of data, right? And so,
Now
uh,
I got it.
yeah, so that was kind of like a joke on the team, but that was like our quick fix that ended up being like an actual really good fix. So we ran into other issues after moving over to HDFS as well, because our jobs ran so quick. We ran into other issues with garbage collection. So we essentially moved over to like GC1 around Spark, I think 2.4. And at that point, we ran into issues where we weren't able to evict garbage fast enough for how quickly
Mm.
streaming pipelines were running. And so then essentially we just get like, we'd be like up at like 20 million objects sitting around in, essentially just waiting to be collected. And so then we'd have to manually flush, doing like the GC flush, which is kind of fixing some issues as well as we were helping basically tuning like the garbage collection as well. So those parameters are no fun. But yeah, I mean, I guess I went over a minute for that one, but a lot of time spent essentially like in the weeds of making applications run, prior to DataFlint being able to analyze that, for me,
Yeah, so we're using the web UI a lot. Let's say
Mhm.
that.
Yeah, we live
Was your
there. Yeah.
yeah.
Well, we also, I mean, speaking of like the web UI as well, almost everything that could be essentially attached as a listener was also being emitted into like Datadog for us at the time as well. So all application listening for like batch jobs to know that it started and it finished correctly. And then for all of our streaming jobs, essentially attaching streaming listeners that could then emit data. So we're using like K-mon metrics for Scala with like the Datadog, whatever metric provider on top of that. And so then essentially as the jobs are running across all executors, everything was just basically, telling us what the state of our job was at any given point in time. And then, that ended up paging us a lot when things went wrong.
Cool.
So,
So
yeah.
after Twilio, you moved to what was the next place? And
Yeah.
is
Yeah.
there which Spark version used there?
Yeah. So after Twilio, so I left Twilio in around like 2022 and went over to Nike as like a distinguished software engineer working in the data platform. And so, well, not technically
So
the data.
that's where when you had time for books, right?
Yes. Well, I had time for books like so in the pandemic, I wrote this book, which was like modern data
No.
engineering with Apache Spark. This is all streaming, all written in Scala, which is why it's 600 pages. And that book was essentially like a COVID project because it's like, what else do I do with my free time? I want to find something that still brings me joy when I can't leave the house. And so I wrote a book. Starting in like
By the
20.
way, to our listeners, three of those that gonna ask questions at the end for the Q&A, we're gonna give the books as a giveaway. So for sure, stay with us and ask questions at the end. And there's a few books that you wrote, so one of them you're gonna get.
I could share another one as well.
Okay.
Yeah, so you
There's
did
the
ask
lake,
about,
the definitive guide, right? To the, yeah,
yeah,
exactly, Delta
yeah.
Lake.
Yeah, so Delta Lake Definitive Guide was like a collaborative project with like a bunch of like friends I had met like within like the Spark community and then the Delta Lake community, and then became like the Open Lakehouse community as well, while I worked at Nike.
Okay,
Um,
I'm updating. I'm back to my setup.
oh,
We
awesome.
are clear. Yeah,
Perfect.
I'll connect.
Awesome. Um, that is still scary. This is the scariest thing that's happened on a webinar so far for me. I'm sitting here
Uh,
talking about
uh,
books and you're like, we're in our safe room, right? We're in the panic
yeah,
room.
it happens on average once or twice a day.
Oh, okay.
So the probability of it happening during the webinar is low, but that's
Yeah.
life.
No, that
And
is.
part of life is of what's going on is continually living your life,
Oh yeah, no, for
right?
sure.
So yeah, no,
Talking
everything's good. We're safe.
Awesome, wonderful. So yeah, you had asked about like the Nike years and like the Nike years. I was there for about 3.5 years, and that was from essentially like that was like Spark 3 days. So starting off in like Spark 3.1, and then moving up to essentially before I left, we were doing like preview for Spark 4. We were also running. This was the first time actually running like Databricks as well. So every other company I'd run, we were doing like purely kind of open source.
No,
And
I'm back
then,
again.
yeah, okay. The all clear, get back in
Back
there.
again.
Yeah. But the
My
yeah,
my wife is also laughing.
yeah. All right, back. So yeah, so with that, it was essentially just a little bit different, right? So rather than us dealing with like optimizations for all the Spark config values that needed to happen for an individual job, or essentially bringing our own predictive optimization to the table, all of that was essentially kind of outsourced to Databricks for a lot of our jobs. There's kind of like minor tuning and other things like that, but like Databricks has stuff like Spark SQL shuffle partitions auto that will kind of analyze a job and make your life a little bit easier, so you don't have to sit there and kind of change things as you go at
Yeah.
specific points in the job. But prior to that, there was a lot of like knowledge in how to set up an application so that it scales through the variability of the life of an individual job as well. And so for a lot of that stuff, it's like still teaching everybody that I worked with. So there's about like 1,800 people in like global tech. Within the Spark community, we had about like 400 like strong like data engineers
Oh
who
wow.
participated, asked questions, learned from each other, and from a lot of that, like we came up with a lot of patterns, different libraries, things like that, to make everyone's life easier. And so that was like a very kind of interesting place to be, because like for me, I was working in almost purely streaming before. And then working at like Nike, there's a lot of like gigantic jobs for like, materials and buying and orders. And what does this all kind of look like versus just kind of like, telemetry for like networking and things like that. So kind of a different aspect, different vantage point of the same sort of problems that I dealt with before, just, for retail versus it being, for telephony. Um,
And it, when you mentioned Databricks, so everyone were using in the company, or it was
no,
different teams chose different, like was it already a Lakehouse architecture
yes.
at Nike? So
Yeah, so
uh,
Nike was kind of an early proponent of Lakehouse. There was a
hmm,
lot of problems with just like kind of pure Parquet. So a lot of issues. So if you think about like kind of column mapping and some of the things we can take for granted now, where it's like, I decided that I wanted to remap these columns, and that would have broken Parquet if you're doing like ordinal offsets. But if you have an open table format that can map that for you, then you don't have to really think about like why this would have broken in the past. We also had schema evolution, which is something that like it's like while you have the ability to merge the schema, don't do it unless you know why you're doing it, right? And so like some of the stuff that were, some of the lessons that I taught people when I was there was essentially like, if protobuf is essentially, the descriptor of what our table should be for foundational tables, and you're essentially ensuring that you have backwards compatibility for your protobuf definitions, and your foundation tables can merge the schema however they want to, because it's going to always be done for the right reason. And so it's like, how do you teach people mental models, right? How do we teach people to do the right thing? Like, going back to like Nike, isms and things like that, right? It's like, do the right thing with your data. and, don't just kind of blindly accept what's coming from upstream unless you understand what upstream is, why it's changing, what it could be changing for. Because in a lot of cases, like, it's very easy for people to just go and replace a table. And you're replacing a table, you might change the schema, you might screw up something else, and then you break all your downstream jobs. And so it's like, well, don't do that, right? Please don't do that. That makes everyone
Yeah.
a little bit worse. But for a lot of that stuff, essentially just became kind of, more or less, it's like, here's rules of engagement, right? If you want to run something in production, then what does that look like? And so to ensure that we had, you know, the right things at the right places, we had like a workspace that was dedicated just for production running jobs. And the only people who could run those jobs were service principals. So
Mm.
you had essentially your sandbox, your playground where you could test everything else out. And then essentially it's like, well, now that we know everything works, let's go use what's actually been certified for production. And now we run everything in production. Did it work? Pretty much. But, there's always kind of problems that still kind of arise from, you know, people pushing things by accident or things like that. But for the most part, we had a good separation of concerns that would prevent people from accidentally, like, dropping tables in production by running a notebook, with the wrong set of permissions.
Yeah, and also I guess if it was like how did you call this environment? Staging or
Yeah, so
what
it's
was
essentially
prior to production?
we called it like development. So
Okay, development.
yep,
Yeah, and I guess one of the problems is you cannot really simulate the data that you're gonna have in production on various aspects, right? So you can take care of some of the things, but
yes,
not many of those that cause the
out of
performance
memory.
issues.
Yeah,
Yeah.
yeah, it's very. I think that's an interesting thing too. If you think about like how like there's a lot of like architecture showed it's like dev and QA and stage and then production for that pipeline.
Yeah.
In a lot of those environments, it really doesn't matter to your point, right? You could be going from something that's working perfectly 100% of the time to something that never actually passes ever. You've never committed any transaction. You've never completed batch zero. And it's like, well, why am I not doing that? Why is this not completing? It's like, well, because this data is enormous, right? It needs to be processed differently. And for a lot of that stuff too, it's like, at least once you've got the data under control, like whether or not you're doing, like AQE, anything else like that for like adaptive query execution, like can you split things in the right way? Do you have to go and manually split and add another job that's processing data to create smaller chunks of data? Like, what is it that you're doing, right? A lot of that stuff could be basically shimmed in if things weren't scaling. But for a lot of stuff, like if you think about like, clickstream and other events and things like that, like it's essentially kind of CPU like IO bound. You're not going to necessarily run into like a lot of other, memory issues, at least like for us, right? That's like the issue that we had. So we had like a couple, it's like 5 to 10 million events a second. But for the most part, it's like that could be run on a very small cluster. It was all just protobuf data.
No, that's good. And I would say that in a sense, later we're gonna have demos. Both you, Scott, and I gonna show something. So I'll touch upon it
Awesome.
because in our case, there's a big difference between what I call build time and runtime,
Hmm.
right? And
Huge difference.
yeah,
Yep.
and today a lot of the build time is accelerated, and there's something you're gonna show, but runtime is still a struggle.
Yes.
Uh, a
That's a
lot
very
of
good. Let's say
yeah,
that's a
it's a
very,
very
very
nice
good
way.
point.
Yeah, yeah, to say.
Awesome.
Okay, so Nike, it was already Spark 3 point something.
So it was a Spark 3.2, Spark 3.2, and then up to like 4.0.0 preview 1 and 2 for
Hmm.
that. So everything that we could test to kind of see like, is it forwards compatible? Like, do we have to change anything? Like, there wasn't a lot of like custom work. Like when I was at Twilio, we did a lot of work with like expression encoding because we had protobuf support essentially starting in Spark 2. So we wrote our own like expression encoder that was essentially just using like it's like the Java, what was it? It's like Java walk tree. I can't remember like the name of like the actual like class,
Ah,
but
I have no idea.
yeah, if you've ever seen like the bean encoder, like the Java bean encoder for like encoders.bean,
Hmm.
it's like the short form for it. All that
Hmm.
did was essentially like walk like a Java object and serialize it so it could be sent to the executors, like the definition of what is in this stage of execution, et cetera. And so because that was an open API, we could extend it because expression encoding was also like a public interface. And so we created like our own encoders for protobuf. And then in Spark 3.4, I think it was 3.4. Yes, it was. 3.4, we actually got like native support for protobuf. And so the Twilio team, I hope they're using that. I haven't talked to them about that, but hopefully they are because it made things a lot easier than what we had written in the past. So
Yeah,
yeah,
got it. So I'm mapping like your career trajectory to the development of Spark, right? And how it changed. So now we have Spark 4 point, well, depends, 0 or parts of 1 if you're on Databricks, right?
yeah,
Uh, so
or even just in the open source world, right? We've got Spark 4.1 and we've got Sport 4.2, in development as well, which is great.
yeah, so when was the first time you started working with 4.7? Was it already at your current job, Databricks, or you played with it at the
Yeah, we're
Nike?
still at Nike. Yep. Yep.
Okay.
Yeah. And then everything that I've been doing recently has been essentially like related to like Delta Lake improvements, Unity Catalog improvements, and essentially kind of like the Lakehouse ecosystem. What does it look like? How do we run it? And essentially like, the job that I have now at Databricks is essentially like advocacy. So I went from like traditional engineering to now helping other engineers be better at using Spark, be better at using like the open Lakehouse, understand, it's like you have a friend, right, who can help answer questions and who will provide like environments to, help you kind of better, yourself, right, within like the ecosystem. So if anyone has questions, always feel free to reach out. I will answer whatever I can. So
Cool. So, as someone who advocates for Spark, which is awesome because I consider myself one of the team, uh,
yes.
give us like an average day at Databricks, if
Oh,
there is if even such a definition.
yeah.
What do you
I don't know.
usually do?
Yeah.
On top of, webinars about Spark, which are fun.
Oh yeah. I mean, so a lot of it, right? Like it's, using a lot of like agents to understand like, what's the sentiment across like specific projects, right? Like how is Spark doing? How is Delta Lake doing? What's like the, trends in Iceberg? What's the trends like against Unity Catalog and like the other kind of open catalogs? Like how's Lakekeeper doing? How's Polaris doing? What's new with like the Iceberg REST catalog? Like how are these things kind of changing in general? And then it's like, are there interesting kind of stories to tell? Are there new things that people might struggle with that are, new ideas? Like for example, like recently, like, Delta Lake's essentially on this, catalog driven path right now. So before with like Delta Lake and like the origin of Delta Lake, you started off with like everything kind of being self-contained files with a self-contained like transaction log. And now there's new support for like catalog managed tables, which essentially uses Unity Catalog and will soon eventually use like the Iceberg REST catalog to be able to, define your table metadata in a way that is no longer bound directly to like, the S3 location where your Delta table lives. So the catalog now knows what's happening. The catalog is now like the arbiter for commits, right? Just like Iceberg. And so, those are kind of like on like this conversion path where it's like, you know, everyone's using the Iceberg REST catalog. That's, sort of ubiquitous across like the entire ecosystem. So let's make sure that, all the open table formats are interoperable with that as well, right? And so there's a path forward for that as well.
And when you say keeping the trends and interacting with the community, so it's more like conferences and this type of engagement, or actually like
Yeah,
also Databricks customers, you chat with them, or this is like solution engineers, solution architects. So I'm trying like to understand the
yeah. So this
delineation.
is this is all specific to open source. Like, so I'm like an open source developer advocate
Oh, got
for
it.
yeah. So like across like Delta Lake, across like Iceberg, across like Unity Catalog, and Spark. And so all of that ecosystem, it's essentially like the people who are actually doing like the work, people who are talking about what they've done, people who would be interesting to also talk with, like you, and other people that I've talked with like over like the years as well, right? It's like, how do we essentially kind of help people understand how to use, you know, our years of knowledge, right? It's like, you know, it would be a waste for us to be like, here's all the things we learned and we keep it to ourselves, right? And so essentially a lot of it's like education, right? Like writing books is also part of that as well. Like what's like the easiest path for people to learn? How do we ensure that like, Claude and ChatGPT understand what we think, right? It's like, how do they adopt the mental models that we have so that, people's lives get incredibly easy, right? Like, what kind of skills can we create so that we can automate ourselves, right? So versus answering like every question that somebody has like 100,000 times, right? It's like, can we answer it like one way, which is like kind of like a definitive guide to, doing something in a way that we believe is like, excellent or like the correct way of doing something, right? And then
Yeah,
how,
well, so you're hinting that you're writing a book for future LLMs?
yeah.
Is that true?
Yes, I'm helping to write like Learning Spark v3. So we're updating it for the
Oh,
Spark 4 ecosystem. But we're also like we're taking against like it's interesting, right? Like nowadays, if people want to read a book, right, you're going to synthesize the book and have like Claude potentially read it for you, tell you what it's learned, right? What it can do in about a minute would take you about 3 months of learning, doing the homework, learning, doing the homework. So if you already have like an understanding of what Spark should do, right? It's like, well, how can you augment that? And so
yeah.
like our approach to this book right now is like, everything that can be run should be runnable with an agent. It's like, can I have, Claude code literally just read the index off of like, GitHub to synthesize and learn more about a specific chapter. If people want to go through and learn things manually, like the old way of learning, they still can. If they just literally want to say, hey, this thing runs, they can do that too. If they want to go and create skills off of it, great. We're going to also provide some skills, but like they can also do it themselves. So it's sort of like back in the day, there used to be like these books called Choose Your Own Adventure. And it'd be like, if you decided
At the end of the page, you can
yeah.
choose where.
Yeah, go to page 96 if you want to, want them to go through the door. Otherwise, take the staircase, right? It's sort of like video games as books. And
Mm.
like, so we're trying to figure out like what is like the next generation of books, right? What does it end up being? And I think for right now, it's kind of like up in the air as things are changing very quickly. But we want to make sure that people will get as much out of this as they possibly can. But if nothing else, it's essentially like, how do we teach skills to like the next generation of people using Spark? Right? Like, the whole name of this is the future of Spark. And I think a lot of the future of Spark is essentially, us conducting agents to, write performance Spark applications in a way that we might have never believed was possible, even a year ago. And that's going to only get better over time.
Yeah, that's a great preface to what we're gonna show at the demo, by the way. It's gonna be focused about like how we do agentic work nowadays. I want to add 2 points to what you have said. So the Learning Spark book, it's like my favorite one about Spark, and I recommend to many who ask me, like people that are new to Spark, what should they do? Even today, exactly, if you wanna get into Spark, um, for sure that book. And actually, it was yesterday or even today, I don't remember, depends on your time zone.
Yeah.
We published a blog post, Manny and I, my co-founder, about like, okay, in the age of LLMs, should you understand like Spark internals? And when I say Spark internals, I mean like Spark concepts, right? Uh, Action, transformation, lazy evaluation, what is a data frame? And my answer is yeah, hell yeah. So unless if you want to understand, what your agents are doing, otherwise it's a kindergarten, and
Yeah. Yeah, you don't want to run it like that. You don't want to just be like, you don't want your agents to just be running around, running into walls and things like that, right? They need guidance. I think of it like a lot like, have you ever done like bumper bowling, where it's like you're learning how to bowl?
yeah, yeah, and
The
you
lanes
have
have like a big
the
balloon or whatever else down the side of it. You can't really screw up, right? You're still learning how to do it. You just don't have the frustration of like getting a sinker or gutter ball, whatever they're called.
isn't it called like guardrails or something?
Yeah, that's
Oh
the
no, I'm
guardrail I
not
think
sure.
at first.
Hmm.
Yeah, I think it's a safer kind of guardrail.
Yeah, cool. So that's my 2 points. So perfect. We like transition through Spark, and today we have Spark Connect, and we have the real-time mode.
Yeah.
Uh, so my view, and I guess you agree now, in a sense, both of them give some a gateway even to agents to run Spark easily, right?
Mm.
Because it's fast, and you can connect wherever you want, right? So I'm curious, give a minute of your thoughts about that, and then we can move to your demo.
Oh, for sure. Yeah, I think, I mean, so if you think about like, so Spark in general is always kind of distributed compute. And Spark Connect came out in like originally kind of like the very, the foundation of Spark Connect was out in like 3.4, and it's been kind of growing within like the ecosystem since then as well. And so if you think about like Spark declarative pipelines, which is like a new feature as of like Spark 4.1, which is also was a kind of closed source feature within Databricks before called Delta live tables, which has now been like renamed as well. But if you think about like, I want to create a pipeline, right? Most data engineering jobs require you to take data from a source, do a transformation or multiple
Yeah.
transformations, and then do something else where you're going to write to a sink or multiple sinks. And so if you think about like what the primitives are for that, a lot of times it's, I have a table, it's a physical table. I've got intermediary data that might be change data feed type data, or maybe I want to materialize a specific view to make things better, or what is it that I want to do? Declarative pipelines give you essentially kind of like an easy button for a lot of that, where you can essentially annotate, specific functions like within Python, and everything else will essentially be, read into a series of kind of intelligent plans, right? So instead of having like one logical plan for an entire structured streaming application, it's like, well, what does it look like if we have a composite pipeline, right? That might be running in multiple, have multiple commits, have multiple checkpoints, et cetera. And so all of that work happens behind the scenes, and you don't have to think about it. And so in terms of like kind of like the evolution of a lot of that, the orchestration is all like Connect based. So it's like, how can I essentially, generate new logical plans and inject them into, the runtime at runtime, right? How do I essentially just, incrementally like, read what this job should be doing? How do I make decisions that potentially a user might want to not want to make on their own, right? And so if
Yeah.
you think about like an agent that, a lot of times we talk about, oh, this agent didn't create the pipeline correctly because the agent is creating like non-deterministic results. If you have something that's a framework that can be then powered by an agent, then the agent has a lot less to think about, right? It just has to do very well, function to function to function. And then essentially it's no different than like, step functions in Amazon, right? I've got data in, I'm going to do something with it.
Yeah. Function and data out. Yeah.
Yep. So it's simple, right? In general, right? Behind the scenes, it's not simple, but if you can draw it on a
When
map,
somebody says it's simple, I'm always like, oh, really?
be skeptical. Yes, be very
Yeah.
skeptical.
Yeah.
Um, but I think with that, like I feel like, Spark can be complicated, like for people who want to get started and understand how everything works. But if you understand SQL and you know how to do transformations in the same way that you would with like DBT, anything else like that, declarative pipelines are a very good way for people to get a lot accomplished in a short amount of time. With real-time mode, it's essentially just, how fast can we get, individual tuples through the system? So what would it look
Yeah.
like if I only cared about individual rows? So instead of like this kind of like unbounded table, right? We still have the notion of like, reading in a way that is, exactly once and or at most once, through our application. We're no longer thinking in batches. And so like the micro batch model is something that I think people have gotten used to over time. But
Yeah.
with real-time mode, it's more of, if you have, a fraud alert or somebody is going to, open up a specific, bank account, whatever else, like these are the kind of the typical use cases. It's like, how fast can you say this is fraudulent or not fraudulent? Can that run directly through like an in-memory model and then have an output that it's essentially going back to, some sort of Postgres database, blah, 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 anything else, right? It's kind of a different operating model than kind of traditional streaming because you're essentially working like epoch to epoch, sort of in the same way that you have like if you think about the way that like a Flink application runs. It's running and all of your checkpoint data is essentially being written twice. It's being written into a buffer and then it's essentially being committed asynchronously over time. So you know what happened within like an epoch. So you can still go back and roll back time and reprocess, but you don't necessarily have to worry about like, oh, this was batch zero, batch one, batch two. That mental model is still there, but you can still operate on every individual row separately.
Yeah.
So it's as fast as
Interesting.
possible. And you're not awaiting a specific stage of execution to be fully complete with all tasks complete. So everything will essentially run through all stages immediately. As long as you've got, available like, CPUs across your executors to run the next step of that execution. Otherwise, it's going to block like a normal Spark app. And so
Okay,
that's,
thank
yeah.
you for that. And I would say to the listeners, so the topic is like the future of Spark. So now we're gonna show you the in the present
Yeah.
the future of Spark. So Scott, the stage is yours and not
All
Spark
right.
stage, but meaning the Zoom. If, feel free to share and show us
All right.
what you've been cooking.
All right. Let's see. Let's make sure this actually comes through. All right. Can you see the
Yeah,
screen?
I'll tell you if I can see. Yes, I can see
All
the
right.
GitHub.
Yeah, so this is like we just talked about like pipeline generation, and a lot of times when people want to generate anything, you know, you need to have something to generate with. And so I created something that's called like PySpark Data Gen. There's a ton of data generators like online. The interesting thing about this data generator is that it understands how to create new data sets based on what I believe are very good tactics for creating like extensible data sets. Um, so what does it actually mean? So I'll just kind of go to the screen.
Mhm.
Can you read this? Is it coming through?
Yes, I can see you're in a cursor,
Yep.
right? And I can see your chat.
Awesome. So I can run everything again, but it's going to take around like 30 minutes. So I'm not going to run everything directly, but I can show how this all works. So we already have like this leaderboard generator. Let's go create another one. What would be something that you're interested in? Be it like, something that's like a time series, for example.
I don't know, my favorite hockey team, and I wanna build some kind of there's the games they played.
Cool.
Uh,
So would be like
I
a
want
fantasy
some
hockey.
kind. Yeah, yeah. Let's go with the that. Although I don't play hockey, it's too hot here.
So that is hockey related. We need to capture plays over time and ranking for team members. Um, is there like a specific league that you care about?
No, you can choose.
Okay, I don't
What's like the best has the most audience?
know. Let's use
Oh,
CS:GO.
the
I don't know if that's like the best one. I'm not super into sports. Um, uh, please take some time to learn about hockey and fantasy sports to uh, do all this. It's a terrible prompt, but so I want to create a fantasy sports based
So
data.
this is like build time. So now we're building using the data gen to generate data we can work with, right? Am I
Yep.
following to this point?
Yeah. And so for all of that stuff too, like, so there's a skill. I'm going to go basically render this one over here. So while this is actually like doing work, which will take a little bit of time for it to actually go do work, behind the scenes, like the data generator is creating like very good protobuf that encapsulates like the data set. So I talked a little bit about like the pattern that I
Hmm.
like foundational data when I was at Nike. So all this does is it basically streamlines that so that nobody has to necessarily be making those decisions other than like, Cursor, any other kind of agent that can read like this skill. And so it's like, IDs and foreign tables, et cetera, like what are required fields, what do messages, nested messages look like, what does the package layout look like? And then also like, how do we generate like, here's like essentially like, generated Python and everything else like that within like our, gen directory. How is it that we can actually use what we've generated from protobuf within the Python context to go create, basically a data generator to now encapsulate, what it is that you need to do with your data. And so this could be stock ticker data. This could be literally anything. You can create time series with skew. You just have to tell it what you want, and then it will go through and generate all of that for you. So it likes
So
to
my
think,
question,
yeah.
Scott, is usually let's say I'm working at Nike, right?
Mhm.
A coincidence, and we have data. So when I'm generating data, it's usually to write like tests, functional tests, unit
Yep.
tests for like the staging environment. So I'm curious at at which point in your workflow you would need to generate data, which is
Yeah.
like
So I mean,
synthetic data, right? That's what we're doing here.
yep. Yeah. So synthetic data is usually like as you're writing a new application that's going to be reading from a source table. doing something, some sort of transformation, then writing somewhere else, right? We need a source of upstream data that is safe to use, right? You could augment this data generator to basically pull data from like a remote source. So if you're in Databricks and you wanted to use like a, an externalized Unity catalog table, you could pull in like the schema of a real table from production, and then use that essentially as the template to create the next data generator as well. So this data generator supports basically JSON-based tables and Delta Lake tables right now. And so it can create everything you need to scaffold, fresh new data, or it can also work with what you already have as well. And honestly, like it will go through and literally does a lot of like work that could potentially also be optimized with subagents as well. I don't have it doing subagent work right now, because it's sort of kind of like barriers of I need all this information now for the next step. But there's probably like, there's
Yeah,
different
so
ways of
there's no
solving problems.
parallelization that you can do,
Yep.
right? Here it's sequential. The
Yeah.
task, I can see the to-do list.
This one's also pretty difficult as well. So this one's working. Yeah. So this one will be
I cho
interesting. It'll
I
run for a
chose
while.
a different one.
Yeah.
Um,
So this one was a leaderboard, so kind of a little bit similar to like the fantasy sports a
hmm,
little bit. But this one is essentially just using like Steam as like a reference, right? So it's like I've got a leaderboard for a specific game. We've got ranks that change over time. So for all of this one, it does the same thing. It uses like the add data gen generator skill, and then it says like what are the concepts, right, for our leaderboard? Like what do we care about? Like we care about an identity, we care about like sorting, we care about displays and entries and time dimensions, right? If I care about ranks over time, then I need to understand how things occurred over time. Um, and then it's like, cool, here's what we believe the data model should look like. I've got
hmm,
no problems with it. Let's move on. This is great. It's doing a lot of the work, a lot of the thinking, a lot of the naming, which is like a big challenge that we have, like, in data engineering as well, even like in the, on the data modeling side, right? What should we call it, right? This makes sense. Player ID, player name, score, prior rank, right? Rank, what's the delta of that rank so we can essentially make it easier for us to take a look at what changed over time, right? How have these players changed over time? And then from there, it says, well, here's essentially what you would need to do because I also wanted everything to essentially be command line driven, right? I want to go and I want to generate a bunch of users. I want to basically go and take those users and ingest them so that I have a deterministic set of
hmm.
players to use. I can run this a million times with the same set of users, right? And then what does it look like for me to write that leaderboard data out? Where is that going to be, right? And then like, all of this stuff, right? This is not super complicated, but this is all you need to know about to go and run things, right? Then also it's like, well, what kind of analytics can we now run in this data set? How is this interesting, right? It's like, who's climbing the rank fastest? What's the score of velocity over time? What's the churn rate? Who's grinding versus who's kind of bursting and coming in like,
Hmm.
occasionally to play quickly, right? Um, and so anyways, I'll just kind of skip through the rest because this could take us the rest of the webinar to go through. So this runs, it runs, it runs, it runs, it runs, it generates a bunch of stuff, right? It runs all of our tests, all the to-dos are done. It will actually go and compile all the protobuf definitions. It will go and create the actual like linked, leaderboard Python output after it's been generated, like from our protobuf. And then it actually uses something which is kind of interesting that I'll show real quick. So if we take a look at leaderboard, so I used to work at a company called Buff, and Buff does a lot of like, there's a lot of libraries you can use in the open source world, and one is a validator. So for this stuff, right, it's like I care about rank and I care about rank that's greater than or equal to one. So all the validations that are written directly against
Hmm.
the protobuf are then used to create the actual data generator so that you don't have to tell it how it should generate good data, right? It just generates good data because the validation passes, right? And it can use that as it's basically learning as well. So the more complicated the data set, the more validations and rules the data set has, the harder it is for Cursor or any other kind of agent to learn how to actually use something. But it's also generated it, so it's like whatever, right? You can go through and you can augment like the protobuf itself if you go through and like step by step by step as you're doing your generation. And then you can use it in production as well. So if you have an API that needs to ingest the same data, now you have validation you can use at the edge, and then you can essentially just emit that directly into like a Kafka stream as well. And so for a lot of this stuff, it's using like, production-based methodologies in a way that kind of feels like a toy project, right? It's like, here's a neat way to create a bunch of data, but it's doing things all in a way that you would need to if you want to create, a good API with like, healthy testing, things like that as well. So scroll through all of this stuff. This is great. Updated its agents markdown to tell people how to use everything. Essentially it's always after every kind of loop, it's just making itself better if it finds better tricks and everything else as well, which is part of essentially like its rules of operation. So at the end of the day, so we'll just kind of go through all of this, right? So we can go create.
So I'm curious, this GitHub repo, we will be able to share it, right?
Yeah, it's already
Yeah,
shared.
so
Yep.
so at
I
the
can
end,
update.
we're gonna share all the resources. Yeah.
Yep. Yeah, and I can actually update this with like the leaderboard and the hockey example as well.
Mm.
And so this kind of goes through, right? And at the very end of it, over here, we can basically go and generate like it does like hourly snapshot generation across like, as many days as you want. So if you wanted to create like 90 days of leaderboard data to go and analyze, you could do all of that. And then you could essentially take those millions of records and, you know, do whatever else you want with it, right? The idea is that you're generating something that's based on like a real world idea because then it creates a better synthetic data set for you to use. But it's also like you can't create like one generator to rule them all, which is why I think that like, LLMs really have a good place in here as well. Um, and everything else it's doing right now, all the analytics and everything else, are essentially one shot through Spark. And it's even adding caching, which is interesting. So,
And I'm curious, so prior to, let's say, Cursor or having LLMs, how long would it take you to build something like that?
this would probably be like a month of my time. Not really. Like I've done this for conferences, like in the past, like when I was working
Mm.
at Twilio, and I think it took about like 3 to 4 days to create something that was like, did we do random seeding, right? Are we doing deterministic generation? If we run this 5 times, are we creating essentially the same data? What does that look like? And now it's essentially something that just runs behind the scenes for you, and it's essentially I don't know, makes life easy. So, anyways, I'll tell you how hockey went later. I can stop sharing
Mm.
because this hockey thing might go on for the next 20 minutes or so.
Yeah, I
Um,
chose a difficult topic. No, that's great.
yeah,
Now I can
I love that.
move to talk about my demo. And again, the transition is interesting because what you're doing is what I called for, even it's prior to build time. Now you just building the data
Yeah, you're
that you,
building the elements right of like a pipeline that can then get stitched together through an actual pipeline. So you could synthetically generate your data, upload that to an actual real table, and then generate your pipelines based off of that to show that it works, which is interesting. All kind of zero shotted for the most part, or kind of like one or two shot.
cool. So I'm gonna share and you see Databricks.
Yes.
Uh, Cool. So it's funny. You are the Databricks and you shared Cursor. I'm not a Databricks and I'm sharing Databricks, but actually I want to focus on like Genie, so the assistant that
Yes.
helps uh, doing a lot of things at Databricks for people that are using. And prior, it was named until like a week ago the Databricks assistant, and then now they added a lot of functionality. By they, I mean you guys at Databricks. And it's really cool. So you can go. So here I have an example. Various ETLs, mostly various operation joins. For this demo, I'll show you here we are writing files. So first we read data. In our case, it's sales data stored in Parquet. Then we repartition it to 1000 and writing it similar to the example I've showed last webinar with Holden. Again, so the problem here is if the data is small and you repartition it and you save it, you save even smaller files, right? So this is the intuition to our listeners. And then when you're reading them, there's an IO bottleneck, and there's other stuff happening. So actually, because we're running low on time, I'm going to show you, you can go to, here we have the Genie code, and you can ask, optimize this notebook. It took too long to run, right? So again, I've done it prior, and it finds the problems. And here it says on this cell, the repartition to 1000, it says cause the full shuffle and wrote 1000 small files. Again, that's also my intuition. Again, this is an example, so it's easy. And he says replace the fix, replace with coalesce 8. So then there's no shuffle, fewer output files. And again, that there is this, I won't say debate, but people are often confused, should they repartition or coalesce before writing files? And there's reasons to use both, depends on use case, right? And in this case, he recommended coalesce 8, and I asked him here, why did he choose coalesce to 8? Like this cell, would it create ideal file size?
Mhm.
Right? In big data, we want a few hundred megabytes per file. And he says, oh, good question. Coalesce 8 was an arbitrary pick and may not produce ideal file sizes. So this is
Still better
something I
than
want to touch
repartition
upon.
1,000. This is to say
Uh,
better than 1,000, right? It's like
yeah, for sure it's better than a 1,000, and it's gonna improve the performance. And the question is, okay, how do I know the perfect number if I wanna improve now the performance? And Genie is great. It has access to the catalog, right? The Unity and all a lot of metadata. It access also your cluster. So it can understand how many cores we have and
Mhm.
see if like, okay, maybe we're not utilizing everything. So again, great tool. The last week I've been playing with it. Super useful. I would recommend. And this is just an example where it's missing what happens in production. So I'm building here something, and in build time, it's amazing. It can write code. It can give me good rules of thumb, right? Let's reduce from 1,000 to, let's say, 8, but it won't tell me the exact number. So then I've ran a session with the DataFlint MCP. So by the way, to our listeners, what is DataFlint? We are a production-aware copilot for Apache Spark. So we understand all the Spark logs and can give exact fixes and help you with performance and costs. We, of course, support Databricks, but also other platforms that Spark runs on. By the way, Scott, here's our webinar on our website. So we were, yeah.
Mhm.
Anyway, so that's us, DataFlint, and we have an MCP also that works with the Genie assistant. So I just added the MCP, and then I asked similar question. I just told them to use the DataFlint MCP, and most of the recommendation were the same. But in this case of the coalesce, he said, "Oh, you can see the sizes of the files because I have access to the Spark logs. I can calculate exactly what's the best recommendation, and the files are super small." So he said, "Do coalesce to 1." And even he can calculate the impact on the wall clock time. So all of the recommendations here, you can do it. So if you're interested, you can contact me or book a demo at our website and get access to the DataFlint that works with Genie. So that's my demo, and my like takeaway from it is building time is almost seamless today. As you've showed, if I want to write some job, any LLM would help me, but when it's in runtime, then we need something that understands on the deeper level what's happening in production. So that's that part. Curious your thoughts, Scott.
I think it's amazing. So it's like if you think about putting all this stuff together, right? Creating, an enormous difficult data set to essentially process. It could be, go back 2 years over, our fantasy hockey league data to create, recommendations for what next year's picks should be. Like I used to work in daily fantasy at Yahoo for a little bit, understanding more about like, that ecosystem, sports bet, et cetera. Not something I like to talk about because I don't really like betting. But it's an interesting data problem. And so if you think about like DraftKings, FanDuel, et cetera, all of that, you're essentially taking a look at fantasy sport data over time. And so I think like with the hockey example, it'd be interesting to be able to go through and say like, what is like, how fast do I want to process this? What's like the cadence in which I want to process new data? And in a lot of cases, like, there are companies doing like aggregate feeds of data, right? And it's like your time to, accurate data point is what people pay for, like for like the aggregate, API vendors of data. And so for a lot of this, it's like you could essentially, if you had a real data set versus like the fake one that I created, ingesting all of that data, optimizing that like with DataFlint, like MCP, understanding if there's better ways of, doing, the build with Genie code, and then having that essentially be something that can then run, essentially as like a managed like declarative pipeline. Like most people nowadays could have a successful Spark application up and running in probably under a day. They just need to learn a little bit about Spark first to understand what they should ask. Because like in a lot of cases, if you one shot with no kind of prior history, it's not very easy to do that, or you might not understand what you're building. And so it's like, sometimes it's cool to watch like all the output in cursor or take a look at like what's being kind of automatically scaffolded, like with like, any of like the Genie prompts that are auto generated within the Databricks environment. But if you don't know, it's like, well, I hope it works. I don't know if it does. Let's ship it, right? It's like kind of weird to
So
think.
you're saying the future is semi in the present already. So if like
Yeah,
even
yeah,
today you can feel
yeah.
it. By the way, you have a few more minutes because we have the Q&A and
Oh
I'm
yeah,
mindful of your time.
yeah. Let's do
So
it.
cool. We got a few questions. So Sven asked hot topic. Oh wait, it jumped. Oh, do you believe data engineering have a higher or lower chance of being replaced by AI compared to traditional software engineering? And let's keep it 1 minute per question, Scott, so we can get as many questions as we can.
That is a very hot question. I think the role of data engineering is essentially merging with the role of traditional software engineering, which is also merging with like, agentic, assistance. Like we're orchestrating essentially the app design. It's sort of more of like a systems architecture type problem now, where it's like, what are the components we need to connect? How should we do that? Do we know enough about what's required at each kind of step along this journey? And then can we create something that encapsulates that idea in a way that's, reproducible, maintainable over time? Like a lot of the same stuff that you needed for software, right? Like the analytic
Mhm.
monitoring, you know, PagerDuty, all these things that help you understand if things are going well or if they're going bad. That stuff isn't going to change. But I think, right, your ability to create a pipeline is now no longer something that's like, it's democratized. Anyone can do it. So that means that,
But I'll be a tough host. Is the
yeah, please be a
probability
tough host. It's
yeah,
a
lower or
basic
higher
pipeline.
chance of being replaced by AI compared to regular software
Oh,
engineers? The
I
data,
think,
I mean, with data engineers, right?
um, I think there's let's say there's a 30 to 45% chance within the next 3 years of AI being good enough to replace uh, kind of junior to mid-level data engineers. If you understand a lot more about the systems, a lot more about like emerging trends, things like that, you can kind of get on top and like ahead of where AI is going. But AI is moving at a pace that I can't predict. Like where I thought things would be now when I talked about this stuff back in November, I'm way off. Like I feel like I'm like 5 years away from where. So I think it's a hard question to answer, right?
So
I
take
think,
it with a pinch of salt,
yeah.
listeners, but that's Scott's prediction. Uh, Holden, she's the MVP. She wrote NHL, exclamation mark. Yeah, we
Oh,
wrote the
not
hockey. Yeah,
US
yeah.
hockey.
Yeah. Okay. Elan is asking, is there a benefit in having so many environments? Question mark, meaning to simulate production data, is it worth having pre-prod environment just for the 1% convergence, a coverage that you can get in end-to-end testing?
3 years ago, I would have said yes. But kind of going back to like the earlier part of like this discussion, um, you don't have like the same economies of scale between like a typical staging environment that you do with prod. So if you think about like being able to, quarantine data within like your production environment and not necessarily have something like available for other people to consume. You can do a lot of like your testing in prod, which sounds bad, right? It's like, there's like that meme with like the Dos Equis guy where it's like, I don't usually test, but when I do, I test in prod. But I think nowadays it's like
Yeah.
you need to be able to test with production data. Um, you can synthesize a lot of it, but you're not going to synthesize, terabytes of data. You could, but you can also like obfuscate real production data and use that as well. If you want to have something that is like safe to consume. And so with a lot of that stuff, it goes back to governance and like, our catalog ecosystem, to be able to make it so that it's safe to use production data as you're creating and, scaling out these applications. Sorry. And my voice is going.
Cool. So I'll take a question by anonymous user. He asked if DataFlint can be used in the free edition of Databricks. So my answer is if you have Genie in the free edition, you can have DataFlint. I didn't check if Genie is supported in the free edition. So that's the answer. Um, Christian asks, is Spark part of the stack for training LLM models? Question mark. What advantages does it have as compared to other stacks, such as Park, Ray on Kubernetes? I'm not familiar with the Park stack.
I
Ray
think
on
with
Kubernetes. You're familiar with it?
Yeah, no, I don't know if it's like the Polar stack, for like the Park stuff. But like
Polars is Park, or maybe I don't know.
I don't, yeah. So I think, I mean, it all really depends, right? Like people can choose, you can choose your poison, right? Like I think with the Spark ecosystem, if you want to be able to handle like enormous scale, that's what Spark's always been good for. And so if you want to be able to, you know, if you want to go train LLMs, like, I don't know what company the question came from. Foundation models are extremely expensive to make. If you want to do that, Spark is used to do a lot of like the pre-processing work to create the data. But then outside of that, like I don't really know how these things work. And so I can't answer that. But for all of like the data pre-processing and for the generation of like, correct data sets that need to be essentially like consumed to create your foundational model, Spark is very much a part of that ecosystem.
Yeah.
And so,
I agree 100%, and I know that OpenAI uses Spark a lot, and they pushing it a lot as part of that. Exactly where it fits in the stack, I don't know, but it's a big player there.
yep.
Uh,
Yeah.
Victor asks, what skills do you think we should learn to keep ourselves AI proof for future jobs?
I think the skills, I mean, if you think about like just like our kind of quick demos, like are you comfortable going and creating, you talk about skills, right? Now we have meta skills because you can create skills and then feed those skills back to agents. But is there something that you can solve that can then be a skill that then saves you time? Like I think in this future of AI, right, we're trying to understand how we can get more output out of people by reducing essentially like the boring work. And so if you can automate your current job out of the way, then new things open up. And so I think that that's kind of where we're sitting right now. Like back in the day, some people used to just kind of take a look at like changing configurations and doing config-based deployments. Agents are now doing all that work, whether it's in Kubernetes, anywhere else like that, like auto scaling, things like that, reacting, first line of defense to paging and things like that. All the things we used to dream of, like when I was on the pager, it's like, how can I automatically understand what's happening? Do I have a guess of what root cause is at 3 a.m? You now have agents to do a lot of that work for you as well. And so it's like, if you're kind of stuck doing the same things that you were doing 10 years ago and you're not using AI to help automate that process, then you're not prepared for what's coming, right? And so it's like if you're looking for what's next and how AI can actually help, steer you in the right direction, it's essentially like, people talk about the co-pilots and everything else like that, but it really is, right? It is something that's there to help you kind of create more of yourself, right? Do you have a perspective? Is there something else that you typically do? Do you understand a problem, from all angles? And then is that something that can be automated? Um, that's what I think, at least. That's kind of the way I've been approaching, my journey through AI as well over the past 2 years.
Yeah, I agree 100%. I said many times my view. I would say on a high level, think of it as a tool. and now it's another tool in your toolbox. If like it's the only tool and you don't understand anything else, you're in a problem.
Mhm.
Uh,
That's like the
yeah,
extreme, right? It's like between like the two versions, right? Like
exactly.
you have to understand what it is you're solving. Otherwise, you don't know if it's working or, whether or not it's safe and secure, right? We had a lot of issues this past week with Light LLM and with a lot of other
Oh yeah,
oopsies. Like, I think in the future, right, if you don't understand what's happening, supply chain attacks are kind of only going to get worse. And so I think security is another thing that people should focus on as well, because AI is very smart at duping us. And so, that's,
great idea.
yeah,
No, that's what the AI says when you say
yeah,
something stupid, right? It says, yeah,
yeah.
of course, but let's do
Well,
it.
we'll run that. We'll shut
Uh,
down your entire cluster. Don't you worry. Yeah,
exactly.
yeah,
Let's put your keys in production, your secret keys. Why not?
yeah. We'll ship it to
Um,
them.
cool. Next question by Ayaz. He asks, I understand the new app using Genie or DataFlint optimization as it goes through the input data, but as most of the data processing happens for big data that can be the sizes of 20 or 30 gigabytes. So how does the input data being read by the Genie to optimize that? Okay, I'll answer that. So Genie works differently. Genie sees it has MCP internally to various Databricks uh, internal data. So it can, I think it can read some metadata from the catalog. So sometimes it can see the sizes of the data or approximate it. That's how Genie works. And again, that's why it's not always correct. DataFlint, what we do, we actually parse and enrich Spark logs with more data, and then we can actually see what happens in the run in production and exactly the sizes of your data. Could be even terabytes. That doesn't really matter because it's in the logs and we can see it and then we act upon it. Okay, question. You would like that, Scott? Nishikant asks, how to use Spark declarative pipeline feature with AI-enabled assistance? So can we combine the declarative pipelines with the assistants?
Yeah, I mean, you sure can. Like, so if you think about like Spark Submit, like right now, agents understand how Spark Submit works. There's a Spark pipeline function that takes essentially like a plan. It's like a Spark pipeline.yaml. As long as the agent can produce your Spark pipeline.yaml, you're good to go. And so in that case, right, you still have to understand what it is that you want to do, right? So it kind of goes back to first principles. So before I was drawing with my hands on the board, that's not really here, but it's like, I've got multiple data sources that need to be fed in. I'm going to do transformations after doing, either stream static joins, stream joins, or basically a bunch of static joins or unions across my data. Great. Then from there, what do I want to do? And so if I think about like Daniel was talking about how DataFlint's essentially reading logs and like, it's taking a look at the planning of your application. The same thing's happening like for STP as well, right? It needs to understand what it is that you want to do to be able to go and create that pipeline. And so as long as you're feeding the right kind of steps to the agent, it can still create the actual pipeline as well. And so really like it's just a different way of working with the same stuff that people are kind of familiar with. The only difference is it works right now only with Python and with SQL. And so for everybody who's like me, who's like, I learned everything for like Scala Spark. For now, PySpark is like the way forward and SQL. So it does open up different ways of working that are all kind of just bound to, I don't know, the Lexer within Spark. So yeah, I don't know. Yes, it
Good.
works. Long story short.
Got it. Yeah, yeah. Cool. Last question. Uh, I'm not sure you're the right person, Scott. I'll read it. Tell me your thoughts. Uh, it's Chanukya asks, with supply chain attacks on the rise, as you've mentioned, Scott, has there been any thoughts around package quarantine controls in Spark, meaning enforcing allow lists or block lists for Python dependencies at job submission or executor startup, beyond what CI can catch? Any existing extension points worth exploring?
Um, so I think like, so if you're working at a company that has like, that's already scanning and creating its own like private like repo. So whether it's PyPy, whether it's like Maven, et cetera, there's already like Spark jars repositories, which will then basically point, your Spark, like on Spark submit, you can basically add like dash dash repositories and say, here's the Databricks, internal repo. This is all of our
Mhm.
quarantined packages that are safe, not quarantined, right? Here's our safe packages. Only use these. Don't go to like, anything, don't go to the open like IV data, whatever, repos,
Yeah.
etc. That's like one way to ensure that it's safeguarded. Other than that, like you can like if you're doing things like within Git, you can basically pin to SHAs of what was safe. And that's been some of the recommendations this week that came out after like the
Mm.
latest supply chain attack. So in the same way that we used to have to do that for Docker, right? It's like I can pin exactly to a SHA, then I know it hasn't been tampered with after release. And so with like the supply chain attack, it's like once all the tokens were there for publishing, say to PyPy, the attack was then kind of going back in time and modifying other versions of similar packages, same packages, et cetera. And so I think that's the scary part too, right? Where it's not just one package, it's unknown, essentially like how far things were poisoned. So I think with that, it's like I think there's going to be sort of a rise of, a lot more, safe repos, whether it's like, private repos as a service, like for, quarantine jars or anything else like that. The time will tell, but it's definitely top of mind for everybody in the space right now.
Okay, and he asked another question, so it will be the last. Spark 4 is locked to Scala 2.13.
Mhm.
Um, and he says, given that Spark's internals are deeply tied to Scala 2.x implicit conversions, the question is a native Scala 3 build architecturally feasible without a ground-up rewrite? Oh, I think there was a similar question with Holden last webinar. So what are your thoughts about that?
Um, so I think my thoughts are if there's going to be a complete rewrite anyways, I'm not sure if the future is going to be necessarily bound to Scala 3. So like if I was to make any kind of bets, like I think a lot more about like the Rust ecosystem. There's a post yesterday about like Spark Connect for C++. Like
Mm.
we probably want more performance like out of things in the future. Like Scala 3 is great, but it's a very wide set of changes between like what we knew about like kind of like
Mm.
Scala between Scala 2.11, Scala 2.12. I think I've had the book like from Dean Wampler for maybe 4 years or so, and so like understanding the way that things change, it's not necessarily cut and dry what it would look like. So I know that there's compatibility mode from Spark 2.13 to Scala 3, but to the point of like all the different changes, I think it would just take a long time to ensure that everything's working correctly. I don't know if it's bad for us to think about like an alternative way of plugging an engine in the future. So as we're talking future focused, and this is also not like a Databricks response, this is Scott's response. So had to put
Cool.
that there.
So yeah, that was last question. I have actually follow-up questions about that, Scott, but we can keep it to the next time we chat. It was super fun. I feel we touched some important topics, but also many things like we only like scratched the surface.
For sure.
So super appreciated of your time and the extra time. And thank you very much.
Awesome. Thank you, everybody.
Thank you to all the viewers, and see you next time.